Hello, today I'd like to explain something regarding the SIKA EC7 Process Multimeter. So this Process Multimeter is an DMM, so that means a digital multimeter in combination with a multifunction process calibrator. So that means you can make a measurement and a generation of different signals. And the setup of the device is a large display, operating buttons, and rotary switch. And with the rotary switch, you can select the different and desired function. Today, I'd like to explain something regarding milliamp measurement, milliamp DC measurement, including loop power. So that means, for example, I have a temperature sensor with a transmitter, and of course the transmitter has to supply it, and we can use the internal loop supply of the device to power on the transmitter, and then the current is measured on this terminal. So that means on the display we can see the milliamp value which is generated by the temperature sensor. So that means I power on the device by selecting the desired function, and on the display you see milliamp in DC, and also the loop power is active and its measurement, and you see the S for the measurement speed. And I like to show something regarding the loop power. You can measure the loop power if you connect a small voltage meter. You can measure in between here and here the loop voltage. That means the internal power supply. I connect to these terminals, and then you can see the internal power supply. The loop power is, the voltage is 25.8.7 volt DC. So that means the internal power supply to power up the temperature sensor is coming out here, and you can make a measurement between these terminals, and then the value is around 25.8 voltage DC. I disconnect this because now I like to connect my temperature sensor, and I connect the plus to this terminal, and the output signal of the 4 to 20 milliamp is connected here. And then you can see the transmitter is powered by this terminal, generate the amp signal, and the milliamp signal is measured on this terminal. And currently we have 8.15 milliamp, and if I increase the temperature of the sensor, then also the milliamp is increased. Yeah. So I heat it up a little bit for higher temperatures. So, and then really the milliamp is increasing. Yeah. So that means temperature measurement by a transmitter is working well, and the loop power powers the device under test. In this case, the temperature sensor, and the milliamp value is measured here. So then you have an additional possibility to make a relative measurement. You can operate this operating button, and that means the value on the auxiliary display is the milliamp value during operating the relative button, and then you see now the value is decreasing, and you see the delta. This is the basis value, and this is the delta value related to the basis value. And here you see the milliamps is minus 0.8 and so on, so decreasing in negative. And if I push again the relative button, then you see even the percentage. So that means the actual milliamp value is 10% below the 10.62 milliamps. So in relative delta deviation measurement in percentage is possible. To come back to the standard measurement, operate again the relative button, and then you see the current measurement of the temperature sensor, including transmitter. You can hold the function, the value. That means in the large upper display, the current value, not the current value, the stored value is shown, and in the auxiliary display, you see the changed value, the current value. And if I heat up again, then you see the upper display is on hold. That means the value is stored. And on the lower display, you see the actual current value. To come back to a standard measurement, you operate again the hold button, and then the instrument will show the DC milliamp. Yeah, that's what I like to explain.